This is Bob Capetta from the College of the Florida Keys, and this lesson is an introduction to radicals. So let's examine the square root of 25. So what exactly is being asked? We need to know what number multiplied by itself is 25. And the reality is there's two answers. Of course, 5 times 5 is 25, and negative 5 times negative 5 is 25. They are both, in a sense, square roots. Both 5 and negative 5 are square roots. But when we write this notation, we want the principal square root, and the positive number is what we're looking for. 5 is the principal square root. So the square root of 25 equals 5. So when we ask for the square root of some number, we want a positive number that multiplied by itself gives us the number under the radical. That's our process. So if I ask for the square root of 9/49, again, I ask myself, what number times itself is 9/49, except we want the positive number so that it is the principal square root. And we know that 3/7 times 3/7 is 9/49. So if that's the case, the square root of 9/49 is 3/7. But there's another way we can think of this. The square root of 9/49 is actually the square root of 9 over the square root of 49. Radicals can behave that way. If you have a radical over a fraction, it's radical top over radical at the bottom. Square root of 9, what positive number multiplied by itself is 9? 3, because 3 times 3 is 9. Square root of 49, what positive number multiplied by itself is 49? 7. 7 times 7 is 49. So two ways to think about the square root of 9/49. Now, if I have this minus the square root of 36, we need to think about what that means. Well, what it means is negative 1 times the square root of 36. The negative on the outside means negative 1 times the square root of 36. Negative on the inside is different. The square root of 36, what positive number times itself equals 36? That, of course, is 6. So negative root 36, or the opposite of the square root of 36, is just negative 6. Negative 1 times 6 is negative 6. But if instead I put the minus sign inside, so I have the square root of negative 9, look at how these two problems are different. Square root on the outside versus square root on the inside. What do I ask myself here? What number multiplied by itself is negative 9? 3 times 3 is not negative 9. Negative 3 times negative 3 is not negative 9. There is no real number multiplied by itself that gives us negative 9. So we do not have a real number answer to the square root of negative 9. So that's going to require us to recognize that if we're dealing with square roots, we will only get real numbers if we start with something under the radical that is positive. So please keep that in mind. But there's another warning I want to give you. When you look at the square root of 64 plus 36, it is tempting to think that it is the square root of 64 plus the square root of 36. I want to show you that that is not the case. The square root sign acts like parentheses. We've got to do what's under here first. 64 plus 36 is 100. So the square root of 64 plus 36 is the square root of 100. What number times itself is 100? The answer is 10. So the square root of 64 plus 36 is 10. Now the mistake that students always make is they think it's the square root of 64 plus the square root of 36. But I want to show you it cannot be that. Because square root of 64, what number times itself is 64? That's 8. Square root of 36, what number times itself is 36? That's 6. And 8 and 6 is 14. 14 is not the same thing as 10. So the order of operations tells us we do what's under the radical first, and then we hit it with the square root. We do not take a square root of each piece. And here's the biggest warning. If you see the square root of x squared plus y squared or something similar, it is not x plus y. We need to simplify it first. So there's a couple reasons why that's the case. All right. So we've been looking at square roots, and we said when we looked at the square root of negative 9 that the thing under the square root cannot be negative. So I want to keep that in mind as we take a look at this function for some various values. So let's plug in some numbers. I said let's look at f of 7. So if I want to know what is the function evaluated at 7, I plug 7 in for x. 2 times 7 minus 5, I do that first, then I hit the square root. 2 times 7 is 14. 14 minus 5 is 9. So do that first. So we have square root of 9. Now, once that's all simplified, what number times itself is 9? What positive number times itself is 9? And the answer is 3. So f of 7 was 3. 7 is in the domain. 7 was fair to plug into the function. Let's look at another one. This one I want f of 4. So I'm going to plug 4 in for x. 4, 2 times 4 is 8. 8 minus 5. Order of operations, say do what's under the square root first. 8 minus 5 is 3. Now I have the square root of 3. What number times itself is 3? Well, it's not a clean one. So you may need to use a calculator to get a decimal approximation, which is what I did. We have f of 4 is approximately 1.732. But that's acceptable. 4 is in the domain. 7 is in the domain. We get real number solutions when we're finished. But let's look at another example. What about f of 0? F of 0 would be the square root of 2 times 0 minus 5. Square root of 0 minus 5, and the order of operations say you must do what's under the radical first. 0 minus 5 is negative 5, square root of negative 5. I'm looking for a number multiplied by itself that equals negative 5. And it can't be a positive number because a positive times a positive is positive. It can't be a negative number because a negative times a negative is positive. So there is no real number multiplied by itself that will yield negative 5. So 0 is not in the domain. 0 is not allowed. So we ask ourselves, 0 is not in the domain. The ones we did on the previous page were. So what numbers are allowed in the domain? Well, the thing under the square root must not be negative. So if I'm looking for the domain of this function, I will say 2x minus 5 has to be greater than or equal to 0. Now, however you're going to solve that, 2x minus 5 has to be greater than or equal to 5. X has got to be greater than or equal to 5 halves. So in interval notation, our domain would be from 5 halves to infinity. So you can't use 2, you can't use 1, you can't use 0, you can't use negative 1. Anything bigger than 2.5, though, would be acceptable. And if you plug 2.5 in, you plug 5 in, 5 halves in. 2 times 5 halves is 5, 5 minus 5 is 0. That would give you an answer of 0. That would be in the domain. So let's take a look at our following function, and we're going to eventually try to graph it. And so I have f of x is the square root of x minus 3. Now, what numbers are fair for me to plug into that function? The thing under the square root has got to be positive, has got to be non-negative at least. So x minus 3 has got to be greater than or equal to 0, which means x has got to be greater than or equal to 3. So our domain in interval notation is square bracket from 3 to infinity. So I'm going to make a table of values to plug in for that function, and then I will graph those points. But I'm going to start with 3, since that's the lowest number in my domain. If I plug an x of 3 in, 3 minus 3 is 0. I've got to do what's under the radical first. That's 0. Square root of 0 is 0. Next up is 4. 4 minus 3 is 1. Square root of 1 is 1. Next up I use 5. 5 minus 3 is 2. Square root of 2 is not a pretty number, so I use a calculator to approximate it, and I get 1.414. Plugging in 6. Square root of 6 minus 3 is do 6 minus 3 first. Square root of 3, about 1.732. Plug in 7. 7 minus 3 is 4. Square root of 4 is a pretty number. That's 2. If I use 8, not pretty. 9, not pretty. I chose to use 12 because that's my next pretty number. 12 minus 3 is 9. Square root of 9 is 3. So I will graph the points 3, 0, 4, 1, 5 about 1.414, 6 about 1.732, 7, 2, and 12, 3. And there are all those points. Notice nothing is to the left of 3. Notice the domain starts with 3 and then it goes as far as I want. So the domain is 3 to infinity. The range, the y values, the lowest it gets is 0 and it gets as high as you want. It would go to infinity. I'm going to connect those points, and that is what the graph of the function f of x is the square root of x minus 3 looks like. So it's a good idea to identify your domain and then choose relevant values, plot a few points, and connect them as we go. All right. Square root of negative 2 squared. The order of operations say do what's underneath the radical first. Negative 2 squared is negative 2 times negative 2 is square root of 4. And square root of 4 is 2. Interesting. Square root of negative 2 squared was 2. Square root of 9 squared is root 81 is 9. Okay. But square root of negative 5 squared is not negative 5. Square root of negative 5 squared is 25. Square root of negative 5 squared is square root of 25 is 5. But square root of 11 squared is 11. So square root of 9 squared is 9. But square root of negative 2 squared was not negative 2. Square root of negative 5 squared was not negative 5 because we always look for the principal square root. So here is our question. Does the square root of a squared equal a? Does the square root of something squared always equal to something? No, the square root of negative 2 squared did not equal 2. But what is it? Negative 2 squared square root became positive 2. The result is the square root of a squared is the absolute value of a. Notice the absolute value of negative 2 is 2. The absolute value of 9 is 9. The absolute value of negative 5 is 5. The absolute value of 11 is 11. So the square root of something squared is the absolute value of the something. So the square root of negative 7 squared would be the absolute value of the something of the absolute value of negative 7, which is 7, which is, of course, true. Negative 7 quantity squared is 49. Its square root is positive 7. So that was a discussion on square roots. I want to finish up by looking at cube roots. When we said square roots, we said what number multiplied by itself equals the number under the radical. Here, what number multiplied by itself 3 times gives us the number under the radical. So here's our notion. 8 is 2 times 2 times 2. I have 2 repeated as a factor 3 times. That's what I'm looking for a cube root. So the cube root of 8 is the cube root of 2 times 2 times 2. Now we look for pairs of repeated factors for square roots. Here I look for triples, and I'm going to go ahead and draw boxes around those triples. So the cube root of 8 is the cube root of 2, 2, 2. Triple 8 leaves me just an answer of 2. Repeated 3 times, the same factor repeated 3 times is my cube root, and the cube root of 8 is 2. But where this gets interesting is when I plug in negative numbers. Cube root of negative 27. And I ask myself, what factor multiplied by itself 3 times equals negative 27? And you might recognize that negative 27 is negative 3 times negative 3 times negative 3. A negative times a negative is a positive, times another negative is a negative. 3 times 3 is 9, times 3 is 27. So I have the same factor repeated 3 times, and I'm going to get in the habit of drawing boxes around those or circling those. I ask myself, what factor multiplied by itself 3 times equals negative 27? And the answer is, of course, negative 3. Now, let's look at how this works. The cube root of 5 cubed is 5, because 5 times 5 times 5 is 125. We just showed the cube root of negative 2 cubed is negative 2. We showed something similar. We showed the cube root of negative 27 was negative 3. So the cube root of negative 2 cubed, cube root of negative 8 is negative 2. Cube root of 4 cubed, cube root of 64, 4 times 4 times 4 is 4. But negative 10 cubed, negative 10 times negative 10 times negative 10 is negative 1,000. What thing multiplied by itself 3 times gives me negative 1,000? The answer is negative 10. So the question we ask this time, does the cube root of something cubed equal to something? Cube root of 5 cubed equal 5? Yes. Cube root of negative 2 cubed equals negative 2? Yes. Cube root of 4 cubed equals 4? Yes. Cube root of negative 10 cubed equals negative 10? Yes. So that indeed is a yes. That was not the case for the square roots. We said the square root of a squared was not a. The square root of a squared was the absolute value of a. So what do we conclude? What's our rule? Well, here's going to be the case, because we're going to have roots beyond square roots and cube roots. Although in this class, those are the ones we're going to look at most often. If k is even, like a square root, a fourth root, a sixth root, an eighth root, if k is even, the kth root of a to the k is the absolute value of a. So the fourth root of a to the fourth is absolute value of a, sixth root of a to the sixth, absolute value of a. But if k is odd, the kth root of a to the k is a, cube root of a cubed is a, fifth root of a to the fifth, a, seventh root of a to the seventh is a. So indeed, if I have the square root of a squared is the absolute value of a. The cube root of a cubed is a. Here's the notation for the fourth root. We would need to have 4 factors repeated to deal with the fourth root. The fourth root of a to the fourth is absolute value of a. The fifth root of a to the fifth, again, that's an odd power, will just be a. So again, if k is even, kth root of a to the k is absolute value of a. If k is odd, the kth root of a to the k equals a. And that will conclude this lesson.